So going back to my banking package, right click and say new Java class, and I will create a customer. All right, so the customer class that I have will have a reference to the account class. So what this thing will have is private account. Then of course I'm going to have some constructors, and that will be public account, public customer, which will take double amount. I will say, how about initial, be consistent with our UML diagram, initial balance. And then, so in this constructor here, I am going to create an account, which is a reference inside class customer, a reference to another class, but customer constructor will create the account, will create it. So I'll just say account equals new account, and I'm assuming that account will take this initial balance in its own constructor. Okay, something like that. So account is created, and that's about it. So we'll say that this constructor creates the account with an initial balance, something like that. So that for the sake of the demo, it'll work, but obviously this may need to be restructured a little bit. So to make things happy from this point on, we need to create another class named account. You can always go to your folder where the files are stored, create brand new text file, and do everything but manually. But NetBeans does it for us automatically when we say this. Just new class, brand new text file is created and populated with some initial stuff in there. All right. So here it is. Everything goes under the package name banking. Here's an account, and I already know that it needs a double balance, account balance, right here, and then it will also need public constructor, which does take double balance, right? And its constructor will simply populate this balance equal to the balance that was initially passed to it. So again, if I move this to another group, you can see that when main method creates a customer, the customer constructor is executed. Part of its execution, it says new account. Account constructor is invoked and is populated with the initial balance that was passed to the constructor. So that now we have customer, we have account, and we have the initial balance. We have all these things in place. So to this level, we should be happy all the way until we say get balance. So Now we all obviously need to add this method to our account. So right here we can say operations, and of course returning a double from get balance. This would be public method get balance would be the way to go, and simply say return balance. Now notice that in my constructor I really don't like to invent new names. For instance, I could say BAL or something like that and use BAL over here. So then I don't have to use this. It should be clear that balance is part of the object data attributes, right? And you know, I could type in here data attributes, right? And then this is a set of constructors. I have only one, right? So, but I am not in favor of inventing those, you know, new names. If it's a balance, let me call it a balance, and this was my original decision. So instead, I will call my local parameter a balance. But to be able to use it right here, compiler assumes that variable names belong to the closest enclosing scope, right? Because this is one of the principles of encapsulation. Stay in the most enclosed scope, in the most current scope. The most current scope is the scope of this method. In this method we have a balance variable, and it has a type double, and it will be initialized when the method is called. Well, method is our constructor of our class. So this is self-assignment. It's like both of these names refer to this local parameter. To disambiguate it, in my case, I am going to say this. I'm going to say, no. This one right here should be accepted as the data attribute of my class. So this is a parameter, and this is the attribute inside my class. So once account is created, right? So once account is created, let me clear this up, right? So once the account is created, right here somewhere in memory, an object is created. It contains this double number in memory and stores the amount. The customer class instance of the customer class right here basically will have a reference to the account. So this is the account class, and this is the customer class. Okay, so first the constructor of the customer is executed. The constructor of the customer class makes a call to a constructor of the account class. Both are instantiated. So now I am fine all the way down to process transaction. So customer is allowed to process transactions. So in my case, to simplify things, customer has should have this process transaction method. So again, I am typing into my customer now operations, and I'm going to say process transaction. As you know, I decided public that it returns a long integer. A long integer process transaction. And what it's going to do is it's going to say, let me see, it's going to say account withdraw, right? Withdraw, and it takes the amount, the withdrawal amount, double. Okay, so this amount will be passed to the withdraw method. Okay. And then this withdraw will give us something that will be a long integer, transaction ID equals 0 to begin with. But then I will say, okay, transaction ID will be returned by the account, which does the number crunching and implements the withdrawal mechanism. So and this particular method will return this transaction ID, which is so far sort of like a mysterious thing, long integer. So here's the withdrawal method on the account. So account allows the withdrawal. And since the withdrawal is the only transaction that we support, it's we'll just say, okay, process transaction, and it's just, we know it's going to be a withdrawal. So going back to the account. Again, let's save this.